Good morning, good afternoon, good evening, everyone. This webinar is from Cambium for the introduction of cnWave 60 GHz product. Today I have, myself, Alan Yu. I'm the product manager for this product line. And I also have Sagar with me. He's also the product manager for this product line. And in addition, I have Olivia from marketing side join us as well. We're very excited to introduce Cambium's first 60 gigs product, cnWave. We have this one announced yesterday. I believe most of you have seen this already. And today we will provide some more detailed coverage about what this product is, how this radio can be deployed and used in what kind of applications. And then we will jump into some product details to share what the feature function of this product. After that, we will have a Q&A session at the end. If you have any additional questions, please feel free to type in the panel. In addition, Olivia posted the data sheet as a handout, so you can also download that one to get more details about the product. With that, let's start. So the cnWave from Cambium. The product is based on 11AY standard. We also have the mesh support there. The product is Telegraph certified. We have 3 platforms introducing the distribution node, which form the distribution mesh layer and also act as access point. We have 2 different client nodes. One is V3000. It's a high gain antenna model for longer range. The other one is V1000. It's a mid gain model for mid range. So the cnWave product line basically delivered multi-gig throughput, and this really enable a true gigabit fixed wireless access for people. The V5000 is a 2-sector radio. With the channel bonding, we can support up to 15 gigabits by the single radio. All the radios support beamforming for easy installation with our end-to-end controller and CM Mastro. We will push the zero-touch installation provision, so it's very easy for operation, easy grow. With the mesh, the network is more like a live network. You can add more, add more nodes and expand your network. In the case you have hardware failure, the routing table will be changed accordingly. So it provides the additional redundancy to improve the overall network availability. All radios are software-defined radio. We support point-to-point configuration, point-to-multipoint, and mesh configuration. On top of that, CM Mastro is a single panel for network management from Cambium. CM Mastro not only manages cnWave, it also manages our PTP line, PMP line, so you have a single NMS, provide a complete end-to-end view for the deployment. So as I said earlier, our product is 802.11ay based. 802.11ay is a new standard of IEEE 802.11. Before that, it was the 802.11ad, which was called YGIG. It was published back in 2016. Compared to 11AD, 11AY provide a lot of advantage. And one of the things is bring a new MAC. We're using the TDMA TD MAC for the access control. So with that one, basically we instead of like the 11AD using CSMA, in the CSMA is ready. Before you transmit, you have to detect any other radio is transmitting. If it's transmitting, you have to pause, wait, and retry. So for a small scale network, low density, CSMA works perfect fine. But when you talk about high density deployment, CSM become less efficient because there's a lot of confliction could happen, and then your latency, your throughput is not guaranteed. With TDMA and TD structure, and we can provide a much higher spectrum efficiency, even in a very dense deployment. Not only give you a much better latency, consistent latency, low jitters, but also we give you a guaranteed throughput. And that's really give a lot of advantage for high density deployment. More than that, we also support network synchronization using GPR signals. So when the radio is TD radio. When we have network synchronization, we will let every node transmit and receive by a given time. So we minimize the internal interference. And with a proper planning, we can do one channel, one network. Meaning is for the whole network, you don't need to worry about frequency planning because we use just one channel, and then the whole network will be synchronized um, to minimize the interference, reach the best performance. More than that, in 11AD is defined the channel size for 2.16 gigahertz. And when we move to the 11AY, we also define the standard defined wider channel of this channel bonding. For our product, we support the channel bonding. Our hardware is ready for channel bonding. So we can support 4.32 gigahertz channel, which means I can double the capacity using the same hardware. The feature is not supported yet by firmware. It will be a feature enabled in 2021. But with the same hardware you purchase today, you turn on the channel bonding, you will simply double the capacity. This also make you can reach longer distance if you want to reach the same capacity like the on the narrower channel, the 2.16 gigahertz channel. So that give a lot of advantage there for higher capacity. More than that, we talk about the TDMA, the network synchronization, channel bonding. This gives us a pretty solid foundation for mesh. Because when you run a mesh, the routing table is depending on the throughput, latency numbers. When your latency is not managed, like in the AD during the conflict, your latency could be long or could be extremely long, depends on the situation. Your throughput also is not guaranteed because you don't know when you have a window you can transmit. So mesh standard really works well under the 11AD. With the 11AY structure, we have a more managed network. So the mesh will works much better. For mesh, we leverage Facebook Telegraph program and we're using the OpenR protocol to support mesh. This provide improved network availability, and we do the auto balance, auto healing, and auto expansion. This really thing much better in the distribution level. So you have mesh layer give you the net availability load balance, and you can grow. So 60 gigahertz is just one part of Cambium. From Cambium, we have the complete wireless fabric solution. Today, with the 60 gigahertz introduced, we ready make the wireless works provide fiber throughput. So we really enable our customers enjoy the multi-gig throughput using wireless 60 gigahertz. So how the 60 gigahertz will be deployed? By nature of the 60 gigahertz, it's very high frequency. And also there is a unique thing about 60 gigahertz is oxygen absorption. Because of that, typically we talk about short distance. And we also talk about line of sight only. It's an outdoor deployment because we cannot really penetrate walls or windows get into the indoor. So it's mainly about outdoor deployment, short distance line of sight. So one application we do is wireless to the home. So we can provide high-speed internet to serve directly to the house. We can also do the wireless to the building. So like we do the rooftop to rooftop connection, and we basically deliver this gigabit capacity to a building, then leverage the in-room, in-house building like Wi-Fi structure to serve people inside the building. The other application is we do the campus connection, and we can do the rooftop to rooftop connection. This can be done for to serve individual buildings, or we can serve the multi-dwelling unit. Because of the multi-gigabits capacity for a single point-to-point link, today we do 3.8 gigabits. With channel bonding, we can do 7.6 gigabits. So this is the perfect solution for the last couple hundred meters or 1,000 meters fiber extension. In the location where fiber cannot be reached the last connection, this already gives you the last 100 meters connection with 60 gigahertz. More than that, 60 gigahertz to form a multi-gig distributed backhaul layer. This can backhaul many different things. We can backhaul 5G small cell. We can backhaul outdoor Wi-Fi. We can also backdoor micro pop solution for smart city for video surveillance. I mean, you can using this to backhaul those because it's just very low latency and a very high capacity. When we see this, we see this radio can be deployed in the city. Okay, and we have cases customer using this one to provide high-speed internet, just compete with fiber or cable operators. In the city where you only have one or two cable operators, this really enables a wireless service provider to enter to this urban market. Second, we see some municipal agent, they using 60 gigahertz to build their own network to either provide for public Wi-Fi or they built smart city to support like police department. They connect to the cameras. They also built their own private network. So this can be deployed in the city for those applications. On the other side, we also see operators. They basically using the 60 gigahertz to provide to serve the residential customers in the building. So what they do is they do the rooftop connection to build a multi-gig RAN or the uh, backhaul layer, and then feed those buildings directly. And that is another application using 60 gigahertz. We see operators today deployed 4G, 5G small cell. 60 gigahertz can also be a good solution for small cell backhaul. When you do the small cell backhaul, we talk about, the latency is less than 1 milliseconds, and the throughput in the point-to-point, both direction is 1.9 gigabits, aggregate is 3.8. So normally we see that one because they need like a gigabit level of backhaul for small cell. What we see is point-to-point or point-to-few point, and with AP in the uh, aggregation side, and then with 2 or 3 node on the remote side. So they can do this point-to-few point, still provide a very high capacity and serve for small cell backhaul. When we move out of the city, we can start serve the resident customers like basically you can serve individual house. We see the cases people build a new community and instead of deliver like using 5 gigahertz to provide 10, 20, 50 megabits, now we can using 60 gigahertz to provide the gigabit throughput. So the peak throughput go to the gigabits, the guaranteed throughput go to 50 meg or 100 meg, 200 meg, and that kind of service level agreement. And this can be done in the dense community, in the urban market, in the suburban market, or the rural market. We can also serve multi-dwelling unit, like this case showing. So basically, multiple households live in the same building, and then we can serve those buildings, and then they have their indoor coverage with their own device. More than that, when we move to the suburban, you can also provide this school connectivities, and that can be used there. So when we move out of the suburban, even go to some of the rural market, we know many different countries, they have incentive from the government to push for a high-speed rural area coverage with broadband. And this can be used for those high-density rural area because, even today, if you look at global trend, people is more living together rather than split, in low density. So this urbanization, really, even people live in this rural area, there are still small, like city center or village center. There's people who live more close to each other. 60 gigahertz can be a good fit for that application as well. So you have using the common 6 gigahertz to do the coverage, and using the 60 gigahertz as a hotspot to cover the high density area with high speed. So this is the kind of like where we can use 60 gigahertz for. Now let's talk about product specific. So we have 3 products we're releasing, and there's 3 models. V5000, the list price is $1249. It's a dual sector distribution node. We have 2 client node, V3000, list price is 674, and V1000, list price is 259. We are accepting pre-orders, so you can also put orders to your local, because we sell through distributors and resellers. So as an end user, you can put orders to your resellers or distributors. You can also go to our webpage and you can find out where you can buy this. So basically, it will give you the name list. You can call to make the orders. The shipping will be shipped out from our distributors by October 30th this year. And also their accessories will be shipped out from our local distributor centers as well. So this is kind of the part numbers. There's one model there's no kind of, like, if you're familiar with Cambium product, sometimes there is kind of like FCC model, SC model, rest of the world model. For 60 gigahertz, it's just one model. So you have one model for V5000. For V3000 is two pieces, but one is the antenna, one is radio. You must order antenna together with the radio. The reason we separate them is rather to make the packaging more efficient, so it will reduce your shipping cost. With the radio and antenna together, that's where the list price 674 referred to. For V1000, everything is packed there: power supply, the power cord, mounting bracket, cable gland. So we have different core options available. So that is ready, the V1000 models. If you're in US, you buy the US cord. If you're in some other country, for example, if you in UK, you can buy UK cord. That's pretty straightforward. So talk about V5000 first. V5000 is our distribution node with two sectors. And you can see from here, a single radio with two sectors. And we have the data from sector 1 to sector 2 is transmitted within the radio. So you don't need any external device to pass the data from sector 1 to sector 2. And with 280-degree coverage, and we can support 30 devices in total. Out of those 30 devices, 4 of them can be DN. So meaning is from every single DN, you can make 4 connections to form the mesh, and then you can grow from there. This gave a pretty good coverage, and when you do the real installation, let's see at the fiber pop site, and you're gonna fit your Ethernet from that location. We have 3 interfaces from the radio. We have a 10 gig copper interface. We have SP Plus interface there. We also have a 1 gig with PoE output. So when you look at the bottom here, you can, if you do a single cable installation, and then you can feed the thing from this single 10 gig copper port. If you want to go with the fiber, we can terminate the fiber here with a 10 gig fiber. We also can terminate the GPON here if you want to terminate on the 5000 directly. And in that, when using fiber, you can still power the radio with PoE, or you can power the radio with a DC input. We also offer a DC to RG45 adapter. This adapter can take the DC input and then feed to the radio to power the radio. So it depends on how you want to power the radio. You can using the combination of that. This is the SFP slot here. This is an auxiliary port. It's a 1 gig copper interface. Basically, we provide 802.380 PoE out, which means if you have a Wi-Fi device or you have a camera, you could power that device from this PoE port. Back to the previous chart, we're saying is because we're doing 2 sectors, we do not need any site routers to pass the data. And in most of the design, we expect single radio per pole. Because when you really form a mesh, the radio need to overlap with each other. So even we have this 80-degree gap here, we really don't see this become a problem in the field. Instead, think about the obstruction, the pole mount you have behind you, or the wall mount, the wall behind you. This pretty much have a pretty good balance between the coverage, and then we make a single radio per pole, simplify the installation by by grid. You don't need any indoor thing. If you already do the relay, you think about you have a fiber pop site. Then when you already grow your network, for those sites where it could be just the power radio, there's no cable come down. Everything is on the top of the pole. Okay, move on to the other platform, the V3000. V3000 is a high incline node. So this one has a 44.5 dB antenna. Today we support a 3.8 gig uplink and downlink. With channel bonding, we can double the capacity, become a 7.6 gigabits P2P link. Even with this high gain dish, we still have beamforming enabled. So we can support 4 degree for horizontal scan and 2 degree for vertical line. And this is very important because the beam width itself is only 0.8 degree. It's pretty, even if we talk about line of sight, still, 0.8 degree is a pretty challenge for alignment. With this beaming capability, this really makes the installation work much easier. More important than that is because we do the auto beam forming, even after installation, the radio will continue fine-tune the alignment. So in the case, if you have small twist or wave of this installation, because of beam forming, you can still maintain a pretty throughput and performance. Rather than for the radio without beam forming, when you really think about your beam width is very narrow. When you have the if your installation was shaped for whatever reason, little twist, then you have to revisit the site to do the adjustment. With beam forming, even it's only 4 degree, but this helps a lot. More than that, the latency is very small, less than 1 millisecond. Typically, it's between 200 to 800 nanoseconds. So it's pretty low latency for point-to-point link. Interface-wise, it shares the same interface like the V3000 because this really is a gigabits provide over a gig throughput. So we offer the fiber interface. We also offer the 10 gig copper interface. Let's talk about the mid-gain client node, is V1000. So V1000 over the air, we can do multi-gig as well. Same modulation from BPSK to 16 QAM. So the top throughput over the air is 1.9 gig per direction. But we kept the interface for a single copper interface. So the radio is powered by 802.3 AFPoE, and we offer the single copper interface. So the radio is not capped by the air, but really capped by this copper interface. So throughput is 1 gig up and 1 gig down. From beamforming wise, we're doing 80 degree for horizontal, 40 degree for elevation. So it's pretty wide range. If you do the point multi-point with V5000, alignment is pretty straightforward. You really don't do alignment. You just point radio to the right direction, then you're done. Because with 80 degree beamforming, you really don't need to you fine tune saying exactly I'm going to point to that direction or not. You just point to that direction, you're good. Power consumption is low, 10 watts. All radios are hardware ready for channel bonding, even the V1000. And our radio also meets the IP66-67 ingress rating. So this is the radio itself. With that, I'm gonna move to talk about the range, give some ideas about the distance, how this radio can support. With V5000 to V5000 or V5000 to V1000, so my chart shown here, the left chart showing a rain rate 46 millimeters per hour with full night link availability. The right one is basically no rain, meaning is a normal operation in a good day, what is throughput you will see. So if you look at the one, we have 4 different channels. Channel 1, channel 1 to 3, they're because they're more impacted by oxygen absorption, so they're kind of like on this side. The orange one is channel 4 because it's more close to E-band, so it's less oxygen absorption. But generally speaking, you can see this throughput also is per direction throughput. It's not aggregate, it's one direction. So we talk about, 200 meters range. From here, basically you will have 500 megabits down and 500 megabits up. Even go to the lowest modulation, we still have over 190 meg up and 190 meg down. So it's pretty high capacity here. So distance about 200 meters to 250 meters, depending on which channel you're using. This is the full night link availability with 46 millimeters per hour rain. This is kind of like the region K kind rain rate, which is largely the area. I think most of if you look at your local, you can kind of like get some idea. If you're better than this, less rain rate, you will be a little bit longer range. If you're heavier than there, you're gonna shrink a little bit more. Do the normal operation. If you deploy on the 200 to 250 meters range with V1000 or V5000, in a normal operation, you are deliver over a gig throughput per direction. So this really gives you the idea, what is my performance under rain? What is my performance in a normal day? When we move to the longer range using V3000, the V3000 basically pushes the distance further because we have a bigger antenna again there. And this one basically showing we're talking about a distance between 450 meters to 500 meters in the multi-point configuration using V5000 with V3000. Again, if we're doing this distance in the normal operation, you're pretty much on the top throughput here for 1.9 gig. This is MCS 12. If you want to have like here's MCS 12 and here is MCS 9. MCS 9 give you 1.1 gig per direction, and one MCS 12 gave you 1.9 gigabits per direction. And when we down to here, it's kind of MCS 5 and MCS 2. Here at the bottom, no, it's MCS 2. So this kind of gave you the multi-point long range idea. When we're ready to do a point-to-point long range using V3000, the distance can push further. We talk about 800 meters range to about 1,000 meters. You can depend on what throughput you wanna achieve. During the normal operation day, the throughput, you're pretty much here. In the extreme case, if you're really saying I don't care about the link availability, I just want to know what is the extreme distance I can reach. So for it's about 4 miles or 6 kilometers. That will be the kind of like the longest range you will be able to achieve using V3000. And you can see the peak throughput will be per direction is 1.9 gigabits, and using the V3000. So with that, let's try to summary what's ready from Cambium. So when we deliver this, when we design the same way product line, one of the key thing we focus is total cost of ownership. And compare with like our traditionally when we put a radio, we put a radio for 90 degree or 120 degree per sector, and then you put multiple radios to cover a site. That is in our PMP 450 line. On the ePMP line, we did that one. But when we move to 60 gigahertz, one big difference is 60 gigahertz is short range. If you want to do longer range, you need using mesh and using itself to backhaul itself to grow the network. So a lot of site will be a relay site because you use a mesh to grow it. And then in many of the pool, if you only have a 90 degree radio or even a 120 degree radio, you need more than one radio because you want to grow it. You don't want a 90 degree, then you literally just point each other. So when you have multiple radios on the same pole, how the data gonna transfer between radio to radio or from sector to sector? You need site routers. When you put site routers, you need additional cables and additional PoE. Things become complicated. And with our dual sector design with 280 degree, we remove the need for site router. We simplify the whole installation, make it very simple and easy. and that greatly reduced the cost of ownership. The second thing is we have the combination for V1000 and V3000. So even using the same DN as access point with the variation of V1000 and V3000, we can meet different need for distance like 100 meters, 200 meters, or a distance further, 400 meters. We can use the V3000, so we can meet different needs using this different CN. All radios support beamforming. Of course, V5000 and V1000 has much wider scanning range, so alignment is kind of like very simple. You just point the right direction. Even for V3000, we have beamforming there. It's not great like wide range because of high gain dish there, but 4 degree give a lot of help and also a much better performance even after installation, because if you do have little twist, you don't need to worry about revisit the site. The beamforming will work because we do not fine tune all the time. Second thing, the V3000 provide very high capacity. We support 3.8 gigabits and with beamforming. And this is the only radio we are aware in the market today can do this kind of throughput and with beamforming capability. Our radio has channel bonding hardware ready, so it's really give you the protection for future investment. When you need to grow your capacity, most likely that will be the case. We know the capacity need is going up, not going down. So with the same hardware, simply with firmware upgrade in 2021, we will enable channel bonding, and then the capacity will be doubled. Our radio IP6667 rated, so it's weatherproof for outdoor deployment. We have high density deployment capability, single DN, V5000, we can support 30 devices. And because we're doing the one channel, one network, so things is pretty simple. We have seen cases for very high density deployment. And in those cases, you can do, if you really need more than 30 in the, say, a 200 meters radius, then you can stack up them. And, if that's the density you really want. For our experience for the customer design, so far we have engaged, we only see one cases need more than 30. Majority case act less than that. So this is pretty support the high density compared 80, only 8 per sector. This is doubled. And more than that, in Mastro, we talk about the single panel for NMS, and we do the zero touch provision and configuration. So in the case you put a new radio there, your basic configuration will be pushed down. When you have a hardware fitted, you want to replace the radio, you don't need to worry about backup the configuration, or I need to reconfigure the thing. All you need to know is the MAC address of the new radio, and then all the configuration will be pushed down with this zero touch configuration. We'll have the AMP tool. This will provide a bigger network planning with mesh. And basically we consider the radio performance or radio characters together with your budget, and we do the balance between the, we provide the optimized design, and then based on your budget information, we built this ROI model in one tool to give you the financial numbers and also performance numbers. And if you want to find more details about the AMP tool, you can find out from your distributors, or you can contact local Cambium sales representative. We can provide more details for that. With that, I think this covers the overall introduction of CN Wave. In the question panel, and we will go through these questions now.
Can you hear me?
Yes, I can hear you,
Alan,
Sagar.
can you hear me now? Okay, great. So I have a few questions from the listeners. Please feel free to add more questions along the way. So we'll be taking any Q&A questions. So Alan, first question for you is it accurate to assume that AD was best effort connection and AY is a dedicated SLA? Is that an accurate statement?
Yes, the AD product, because it's using the CSMA for channel access, so it's for low density, you have less conflict, so you have you have a pretty good performance. So it's best effort. When you move to high density, when you have more confliction, the latency become a challenge. The throughput is not guaranteed, and with AY, there is a big improvement with the new TDMA, TD-MAC PHY, design. This really gives you a managed network with a guaranteed latency and much lower latency, a controlled latency.
Right. Thanks, Alan. Next question, I think it is to kind of reiterate, how many subscribers can the V5000 have, and how many of those V5000s can connect to other V5000s to form a mesh?
So we talk about the V5000. V5000 has two sectors. Each sector can support up to 15 devices. So two sector, we support 30 devices. And every sector we can connect to DN. So two sectors we can connect with 4 DN. So from V5000 to V5000, you can connect up to 4 to form the mesh. And total is 30 devices. In the case you have 4 V5000, then you have 26 left over for seeing connection.
Understood. Thanks, Alan. Next question is, I think during the webinar you had mentioned on the MSRP. Could you reiterate the MSRP for the V5000, 3000, and 1000?
Sure. The list price for V5000 is $1249. For V3000 is $674. If you remember, for V3000 there's two pieces. One is a antenna piece, one is a radio piece. So there's two part numbers. The radio piece is $599. The antenna piece is $75. So a V3000 radio complete is $674, and the V1000 is $259.
Thanks, Alan. Next question is, can you go to the distance and MCS rate modulation and just kind of talk through what would be the max distances for V5000, V1000, and V3000, V3000?
Sure. So I think this one showing the V5000 to V5000 or V5000 to V1000. The distance are the same. As we said, this one, it's the left chart showing the 4.9 with 46 millimeters hour rain rate. The right chart show you a normal operation. I think if you really want to see the your specific area, go to the link planner. The link planner, we're using the rain rate accuracy to 30 meters. So if you put your location, you just do because right now it only do point to point, but that's okay. You do the point to point, and you can using V5000 to V1000 or V3000 or whatever combination, and that will give you a precise distance, or precise performance by their given location. If you really want to push for extreme, saying is I don't care about link availability, which is unlikely to be the case. You do want some level of maybe not a 4.9, maybe you want to do a 3.9. But in the extreme case, we're talking about 400 to 500 meters range with channel 1, channel 3. With channel 4, you will push to about 600 meters, could be a little bit longer. That will be your extreme case. But in that case, really, if you're really in the desert with no rain at all, then you'll be okay. When we talk about the V3000, I think I mentioned for V3000 to V3000, extreme case is 6,000 meters or 4 miles. But if you think about, same thing, link availability, the link planner gives you the idea. For point to multi-point, we talk about extreme case, you can do channel 1, channel 3, we already talk about close to 1.3, 1.4 maybe here. And if you're doing the V3000 long range, I think you can do 2 miles without worry about link availability.
Thanks, Alan. Next question, I think you already answered it. But other than link planner, so what is the difference on a high level between link planner and the AMP tool from a customer trying to use it or understand it?
So link planner is a tool we published on the under Cambium support webpage, and you can download, you can play. I'm sure many of you already using link planner for our licensed microwave or 5 gigahertz. So there's no difference. This is just another 60 gigahertz radio there. For AMP tool, the tool is not open for end user. The tool is open for distributors, and because the tool using LiDAR data to really provide a precise design, and also it will give you the, depends on your input, it will give you a optimized ROI model to show what is the best way or to meet your requirement. You can ask the MP2 details from your distributors, or you can also check the MP2 from Cambium. We also provide the service for that using the AMP2 for network planning.
Right. Thanks, Alan. Next question is, does CN Wave include any license keys? If yes, which do you see mentioned over here?
At the initial release, we're not include any license key, so you get the radio, you pretty much get all feature functions opened. Down the roadmap, the radio will support channel bounding, as I said earlier. The channel bounding will be a license key controlled feature. So to enable channel bounding, there is a fee for that. Second is the on the radio side, we will support 1588 precision clock. Once that one is available, that will be a license controlled feature. And we also plan to introduce a CM Vision version for CM Wave product line. So basically be more friendly for cameras. You know the CM Vision from our 5 gigs product line. So a difference is we're not selling a different hardware. It will be a software feature to turn on the video related UI and features. That will be a license controlled feature. So that's on the radio side. On the other side, we talked about CM master support for CM Wave. So if you do a point-to-point or point-to-multipoint using because using the CM Mastro, they're covered by our standard CM Mastro package. If you want to turn on the mesh configuration, it is supported by the CM Mastro X feature function. So today, many of the feature function of CM Mastro X, it is still free as you're using our CM Mastro. But once the CM Mastro X is released, there is a charge on the mesh configuration. If you want to turn on the mesh configuration and using CM Mastro for the overall control, there is a subscription cost for that. And for the details, you can check our sales representative or check the distributors, and you can find that information.
Right. Thanks, Alan. Next question. So the original Telegraph mesh is based on layer 3 IPv6, whereas Cambium solutions are typically based on layer 2. How do you see CN Wave integrating IPv4 and IPv6 together to form a cohesive solution?
It's a good question. So as you're all aware, the OpenR or Telegraph OpenR protocol, that is layer 3 based on IPv6. But our radio do support layer 2 tunneling. So from release 1 for small scale, when your size is limited to 20 nodes, we are providing layer 2 tunneling. So we're still IPv6 based, but when we turn on the layer 2 tunneling, it's more like a layer 2 function. So you don't need any external device worry about the convert or support of IPv4. And in the second release, we will also support IPv4 support on the mesh configuration for bigger scale, and that is supported still. The foundation is still IPv6, but then we're using a different protocol to support large scale IPv4 network over wave.
Thanks, Alan. There's a question. So the next question is, how fast is the beam forming adjusting? For example, if the pole sways a little bit in the wind, does it constantly compensate?
So the beamforming has two ways, or so when you do during the installation, it's constantly adjust, trying to basically find the best connection between the two nodes. And once you finish the installation, then they kind of like, I know where my direction is. And during the operation, the radio still periodically recheck the performance. And if you lost the link, it will go back to the alignment mode. Then you really gonna fast track realign. But if you're not lost link, just saying you're a little bit twist. If you're let's say you're off by a little bit, but still the radio make the connection, it found it's not on the optimized configuration, and every 4 hours it will do a realign, and you will not see any link job. During the realign, it will basically remember the best direction to reach the best performance. So with that one, periodically, even in operation or you lost operation, the beamformers keep tracking where the right direction it need to beam with.
Right. Thanks, Alan. Next question. So you mentioned the shipping date. So the question is, these units, the date that you've mentioned, October 30th, is it the day it's being shipped from China, or is that the day they'll be shipped by boat to the distributors? Or what does exactly the October 30th date imply?
October 30th means we're shipping from our distribution center from Shanghai. We are helping our distributors to ship the product by air to each country or continent. Using, let's say, North America as example, we have program working with distributors to bring the radio by air to meet people's need for early quick deployment. So if you have the need, please working with your distributors, and I expect people will get the radio by mid of November. You will have the radio in hand. Working with distributors, your local distributors to get the radio. That's my recommendation.
Understood. Thanks, Alan. Next question. In the accessory slash part numbers that you had mentioned, for the power supply for the V5000, you had two options. One is the 60 watt one is the 100 watt one. Typically, what guidance would you give customers when choosing between the two?
Okay. Okay. Let's talk about this one. Okay. So they are two configuration. I mean, this is the V5000. There's two ways you can power the radio. If you go with a single cable option, then you already power the radio by the copper interface, right? Passive PoE. And today we offer a 5 gig 5 gig PoE 100 watts. So you can power the radio from here as basically a single cable solution. This is option one. Okay. Option two is using the fiber. So let's see, I using the fiber connection here. Then in order to power the radio, you can go with any PoE as long as it has the enough power So basically any, even like PTP 670 PoE, you'll be okay because you ready the data, your data come from this port, you just want to power the radio. So that's option one, maybe option two. So you go with the fiber, you have the fiber option here, and you're just using a PoE, a normal PoE. You don't need a 10 gig or 5 gig PoE because you simply just want to power the radio. The third option is still under the fiber, right? You have the fiber here. Then you can power the radio by a DC. When you do the DC option, you just buy a little mini adapter. So adapter is like this big, and one side is RJ45, the other side is 2-pin or 2 connectors, DC for DC connectors. And you can plug in this mini adapter into here, and then you have using the long cable gland to cover it. Then this is the option 3. So when using the DC, we also offer 2 different AC/DC power unit. One is 60 watts. I think that's what your question asking. One is 100 watts. It really depends. The radio itself is 35 watts. So, but when you're using the auxiliary port for PoE out, this one is a 25 watts PoE out. If you consider the cable stuff, so normally we put a little bit more buffer here, 30 watts. So this become let's say run at 30 watts. So really, if you're using PoE, then you go with a 100 watts AC/DC power unit. If you're not using the PoE, 60 watts AC/DC power unit will be good enough. So let's just talk about this DC power. Okay. Sagar, any more questions?
Yes, Alan. So the next question that we have is there any plan to have a 5 gig backup for the existing 60 gig? Can we use something with the aux port for that?
Good question. So we do. This is mainly for point-to-point because when you do the mesh layer build the redundancy already. The question is more about using the kind of like V3000. When we're using V3000 to a point-to-point, if I want to have a backup, what I do. So there is a plan to support a 5 gigahertz failover using the auxiliary port because we have the power supply here. We can power, say, a Force 300 radio, and then or 550 radio. Then we can do the failover. It's not supported yet. It is definitely in our roadmap, and it will be supported in 2021.
Thanks, Alan. Next question is, are CN Wave products planning to use 1 gig channel instead of 2 gig channel, or do they have it in roadmap?
Okay, so currently we're using 2.16 gigahertz channel, and when we do the channel bonding, we're gonna support a 4.32 gigahertz channel. We have no plan to support the narrower one, the 1.08 gigahertz channel.
Right. Thanks, Alan. Just to reiterate, can the V1000 connect to another V1000 to form a PTP link?
Okay. Another good one. The radio, all radio are software configured, so you can using whatever whichever end. You can have a mix. The only exception is V1000 to V1000 point-to-point mode. That is not in the first release. It's not any hardware limitation. It's just right now the priority we put in there. The point-to-point mode for V1000 to V1000 will support in the second release, and that will be supported in the future.
Thanks, Alan. Next question. Is the GPS that we mentioned built into the radio for the V5000, or is it something separate?
Sorry, can you repeat the question again?
So is the the V5000 contains a GPS? Is it built in, or is it like a separate device that needs to be connected?
I see. So V5000 has GPS built in. So it has a GPS receiver on top of the radio. So you don't want to put a metal piece on top of this to block it. That is in the radio. Same thing on the V3000. It's on the back. So V3000 also have the GPS receiver built in. Um, so in this one chart. So this one's here, and this one is here on top. The V1000 they don't need GPS receiver because it's synchronized using with the V5000.
Right. Thanks, Alan. Next question is, how many hops or how many hops would you recommend for a deployment of CNWave?
So we recommend no more than 15 hops from the fiber location in a mesh or a multi-point configuration. This is not limited by the hardware or by the design. So it's not really a technical limitation. This is more about a guidance for planning. The concern is more about latency because every hop is 1 milliseconds. Then when you have 15 hops, given the round trip, it's about over 30 milliseconds then. So it's 15 hops from fiber location is our guidance.
Right. Thanks, Alan. Next question is what kind of encryption do we support on CNWave products?
We do support 128-bit AES encryption. That's a default function of the radio.
Right. Thanks, Alan. Next question is, so for basically this is related to starting a mesh. Would you recommend one fiber pop or multiple fiber pop in different directions? And if you recommend multiple fiber pops, how do you resolve the routing and solve those kind of routing issues?
It's a good question. So it's really depends on how your network looks like. Let's assume your fiber pop site is 10 gig, right? And then normally from there, let's say you put a V5000 on the fiber pop site, then you connect with 3 or 4 DN, and you start to extend your network. Um, so then you're gonna consider what is the service level or committed throughput you want to provide for your customers, and typically we don't, for a small network, let's say you have 200 customers you want to serve, we see 1 or 2 pop site will be good enough. I think the more pop site is more about the capacity. You don't want backhaul or this fiber pops become a bottleneck, right? So for that purpose, you want to have multiple fiber pop. Second is for redundancy. If your whole network has a single fiber pop site, if there's something wrong with this fiber pop site, then you lost the whole thing. So it's more about redundancy. You can have 2 or more. When we talk about the routing, so the system, the overall network, the whole routing table is maintained by the end-to-end controller. On the end-to-end controller, we take the measurement of the capacity and also the measurement of the latency, and we will determine how the data will be rerouted to where. So that is all done automatically by the end-to-end controller using OpenR protocol. And the algorithm has been proved and tested. If you go to the Telegraph web page, Facebook, there are several network has been deployed, like in San Jose area itself, and Hungary, in Malaysia. There's different network has this mesh function there. with multiple fiber pop site. It's a field-proofed protocol, works very efficient. So the numbers, it really depends on your network service level you want to commit or provide. Um, there's no hard line say you need to have 5 or 2 or 1. Of course, you need minimum 1, but if you more than that, it's really your choice.
Right. Thanks, Alan. A quick question. So what are all these CNWave products available on Link Planner for planning today?
So today I'm seeing, if you go to Link Planner, the latest version, we support point-to-point configuration for all 3 models. The only one is V1000. V1000 is not there, but you can do a point-to-point 5000 to V3000 or V3000 to V3000. So you can or V1000 to V5000. You can do that in point-to-point mode. The point multi-point will be supported this month.
Right. Thanks, Alan. Next question. When would mesh be available? Is it sometime near future, or do you have a timeline for that? And would it be a part of on-prem cloud only, or would it be a CN Mastro X version?
I see. Good question. So today, the CM Astro will be released in day 1. So when we release the product, CM Astro is available day 1 to support CM Wave. It will be on the on-premise first, and then it will go to the cloud. If you're familiar with CM Astro, we always have not most time we do not release at the exact same time, but the same function, no difference. It's just a matter of some additional tests we need to do. So at the very beginning, it'll be on a premise version for CMS, same with support, and then it will be support on the cloud version. The CMastro X will be supported later this year. For the details, please check with us for the. I think it's ready. I need to check with our CMastro product line manager for the X will be officially released. But all the feature function, like I said earlier, the mesh support is an X feature, but this feature is available in day 1. It's just it's an X feature, but it's available day 1, so you can use the same Astro for all the function you need to use.
Understood. Thanks,
And it's
Alan.
free.
Quick question. Sorry. Quick question is, do customers require FCC
Sorry,
license
go
to
ahead.
buy the CNWave products?
So we are doing so 60 gigahertz in North America or US is unlicensed. So as end user, you don't need to do you don't need to apply any license. In most of in other countries, like in Europe, ETSI has proposed the 60 gigahertz as well for unlicensed use for both point multi-point and point-to-point. But every country, they have to decide when they want to open by themselves. So last year, actually, we see the UK is opened. In Czech Republic, they're light licensed, and Italy, France, German, country by country is slightly different. Some countries open, some countries considering. And if we move out of that one into Asia, in like India, is still not open yet. It's working in progress to be opened. And in Malaysia, it's opened. Singapore is opened. Australia is opened. So it's really by country. We are working with a local regulatory body and to help them to define those standards. And basically, we are very supportive to open more spectrum. Generally speaking, globally, 60 gigahertz is unlicensed band. We are doing our own homologation by country, by different SA and FCC. So that's covered by Cambium. As an end user, really, I think it really depends on where you are. I would recommend if you don't know it's open or not, please check with your local Cambium reseller or Cambium sales representative. We can provide the details about 60 gigs is unlicensed in country, or it is still a license, or it's not even open at all. in the specific country location.
Thanks, Alan. One more question related to L2 tunneling. So we have talked about what L2 tunneling is and how it affects. So the question is, if you're doing it in point to multi-point, is each subscriber radio a tunneling endpoint? And where does the other end of the link terminate? For the V5000 at the edge of a network, or is it a third-party concentrator?
So when we do the layer 2 tunneling, we don't need any third-party device. Everything is done within the same wave itself. So if we take a very simple point to multi-point as example, so one end is on the V5000, the other end is on the CN side. Either it's V1000 or V3000. So we do the tunneling all internally. No third-party device required.
Understood. Thanks, Alan. I think we have two more questions. Please feel free to ask any more if we may not have covered any specific sections. So last two more questions. First question is, what is the max TX data rate for per channel? What is the maximum throughput TX wise?
Yes, we're doing 50-50 for allocation for uplink and downlink. So the highest throughput will be 1.9 gigabits using current channel size. When we do the channel bonding, it will simply double to 3.8 gigabits per direction for
Understood.
single channel.
Understood. Thanks, Alan. And this is the last question. Are we going to provide any sort of product training or product support or product understanding?
Yeah, I think this is one of the best one. We do have online training courses published under the Cambium Learning webpage. It's an online course. You can log in and using your own pace to go through the training. There's 3 models there. One is overall product overview, give you very details about feature function stuff. The other one is the operation overview, so give you the idea about the frame structure, the configuration details, and then there is an installation part, also tell you how the radio to be configured and installed. There are 3 modules there. Each of them is about, I think it's about 45 minutes long. So please, just log in. It's free. You do need to open an account there to log in. And then once you log in, just follow your own pace, go through the CN Wave training courses there. All right, I think Sagar, thank you very much.
I think those were the
Actually, it's
questions. Yeah, thank you.
Yes, I see. I don't know we covered all the questions or not. If you put your question under the panel, we will summarize all the questions and provide answers together for this webinar. It will be posted in a couple of days and under our webinar session. So you can all check the questions and also replay if you have if you have any colleague missed this webinar. With that, we're gonna call the end for today's webinar. Thank you very much. I think we have this is ready the day we turn the wires to be a fiber solution. Thank you very much. You all have a good day.